2 minutes after that poop just to like recover. I was like kind of shaking. Were you emotionally there? Alright, there's your 6 seconds of copyrighted music. Time to switch to reverb. So I've been working on this game for over a year now, and it's kind of crazy to see how far we've come. Astro is a multiplayer FPS in zero gravity, and the main focus of the game is on movement. Considering how much Astro has changed, I figured now is a good time to look back on how much has happened in the last year of development. The idea for Astro is actually a lot older than the current project. When my brother and I were in elementary school, we had this fantasy universe we created through countless drawings of cool characters and weapons, and the whole thing was intergalactic and probably heavily inspired from Star Wars. Then we discovered first-person shooters, and we were obsessed with Call of Duty and Battlefield 3. We combined these ideas to form the initial concepts of an FPS in zero gravity. Fast forward 13 years to spring 2022, and I was finally ready to resurface these childhood dreams and make our idea reality. Actually, before this point, I had prototyped the game twice, once in Unity and once in Unreal, but I never really stuck with either. The game was originally called Acto, since one of the planets from our universe was called Acto, but later somewhere along the way, I renamed it to Astro. So my first focus was on making the map for the game, because the bricks just weren't going to cut it. I didn't know how to 3D model, so I figured that my solution would be to procedurally generate an asteroid. The game idea, somewhat similar in concept to shooters like Rainbow Six Siege, went something like this. 2 teams battle it out in outer space. One team starts inside the asteroid and must defend it while the other tries to invade it. I had big plans like everything would be destructible and all players would have tons of gadgets and weapons. After bringing in a marching cubes algorithm which I had made in a Unity project a year before, I finally had something good working. I tried to test it in multiplayer and everything went downhill from there. The game was jittering heavily and sometimes the player would just spin forever. Other times they wouldn't even spawn in. I was kind of confused and I did some quick Google searching to find out that I had made a horrible oversight. See, I was simply treating the player as a physics body and then adding forces to it when the player pressed the key inputs. This does not hold up whatsoever on a network. Undeterred, however, I started learning about this thing called client-side prediction. I spent a few days researching it before just diving headfirst into making my own client-side prediction physics system. My very linear process for networking physics was first to create a rudimentary physics engine and then try some bizarre tactics to network the data between the client and the server. Surprisingly, it kind of worked, but with a lot of caveats. Realistic pings were still really buggy, and I had to represent the player as a sphere since this greatly reduced the network complexity since spheres don't need rotation. I was proud of the progress, and I decided to hold the first ever playtest with my friend's computer as the server.
I versus Rishi. I have some beef with him.
Ito third partied my ass.
Third party?
Cringe.
The other guy's dead.
It was definitely not a bug-free playtest, but we were actually able to get enough fun gunfights for me to think, just a few bug fixes and minor features from publishing this game. I could not have been more wrong. I came home from the first year of college, and now I had the whole summer in front of me. I also started working on my brother's gaming computer, and you know you've been at an all-time low when you're excited just to have a GPU. Equipped with better gear, I grabbed an asset pack for placeholder gun art, and I got to work leveling up the asteroid graphics. I switched over to a voxel plugin to procedurally generate the map, which allowed me to use custom materials, and then I proceeded to go absolutely crazy with the shader graph. I also decided to cut the entire custom network physics engine I made. Yeah, instead I used Unreal Engine's character movement component after I saw how many features Unreal offered that I simply had no clue how to make on my own. The second playtest on this new map went much better than the first, with more gunfights and crazy action. Unfortunately, I discovered that the procedurally generated maps are not performant at all. See, I was developing on my brother's computer, which held up surprisingly well against my shaders, but my friend's laptops didn't stand a chance. I had to lower the quality to a disgusting green slime, and I knew that after this playtest, I'd probably need to scrap procedural generation entirely. So I got to work making the first handmade map, Laboratory. In hindsight, it looked like something created by someone with no Blender experience and even less understanding of color theory, and I threw it into the engine anyway. Even though this was virtually my home for hours of playtesting, I still never truly learned the map. In terms of level design, it was a nightmare. Well, in terms of everything, it was a nightmare. If the first map looked like an acid trip, then playing Laboratory was like a crack detox. I spent the rest of the summer working on movement. I added some cool features like dashing, stomach sliding, and rail swinging. As the summer came to an end, I wrapped up V2 with a playtest on the new map. This was the first playtest that actually felt close to an FPS match, and I was pretty satisfied with the current progress. Looking back now, I truly did scrap almost every feature from V1 and V2, but at the time, this didn't dishearten me since I was always thinking I was only a few months out from publishing the game. I came back to college with my brother's PC, some flex dollars in my pocket, and a fresh ambition. Having recently committed to making handmade maps, I decided it was finally time to ditch the asset packs and default mannequin and learn Blender. In my spare time, I also did more research on the character movement component, and I started reading the source code to understand how networking movement actually works. I realized that so much of the functionality of the networked movement in Unreal that I started using in Astro is not documented whatsoever. I was upset by the lack of clarity, so I decided to make my own documentation on how to correctly use the character movement component. I never had the intent of becoming a tutorial channel, but I ended up creating an 11-part series, and at the same time I was making giraffes, laptops, and other random things to practice my modeling skills. By the end of the semester, I had modeled a couple of characters, and I was ready to finally make a map. Coming home for Christmas, I had a big present waiting for me. For myself, of course. I had ordered the parts to build a new PC. My brother's rig was starting to fail me, especially in Unreal Engine 5, and I think he was salty that I used it more than he did. But my new computer was an absolute beast. I got my brother up to speed with the game idea and 3D modeling, and then we took off, grinding the new map. We put some considerable effort into level design as well, playtesting the blockouts before we committed to anything. Then we actually did all the modeling for the map in 1 week, which sounds kind of crazy. Probably because it was crazy, but it turned out to be worth it. I was really impressed with the level of quality we were able to achieve with such little experience and such a short time frame, and it gave me hope that we could maybe make something worth publishing. Going back to school for the second semester, I did a lot of work on the character and the animation system. I also reworked the slide and removed the dash, adding the push ability instead. All of this culminated in a playtest on the new map with the all-time fewest bugs and some pretty decent gameplay. The guns and movement were starting to feel satisfying, and networking was much less jittery, especially for being a remotely conducted playtest.
You're moving into a land of both shadow and substance, of things and ideas. You've just crossed over into the
V4
zone.
So this brings us to V4, which is the current chapter of Astro. I was having some difficulties with the movement system not cooperating very well, and I was getting frustrated with the CMC. I then moved on to tightening up the weapon netcode and trying to strictly enforce server authority hit registration, when, to my surprise, I discovered that Unreal Engine does not support deterministic proxy simulation or a shared proxy snapshot timestamp. To be honest, I don't really know who my target audience for this video is. You don't need to worry about what that means, just know that it's absolutely critical for lag compensation. And without it, you need to use client authoritative hit systems, which obviously allows cheaters free rein to hack your game. This was the last straw, and I finally decided to do the unthinkable: rewrite a networked physics system. This time, armed with my fluent understanding of Unreal Engine's network solution, client-side prediction, and more, I was fully prepared to slay the beast that defeated me just 1 year ago. The early prototypes were a bit scatterbrained, but I eventually converged on a very elegant solution: the NetTick system. It's not easy to explain, and it's also official Astro IP, but the main design feature is using simulation containers to isolate movement-safe variables and update the game logic in a clean environment. To keep the system as generalized as possible, NetTick actually lives in a separate plugin outside of the game, and it doesn't even know about Astro or the movement system at all. All the implementation logic is in derived NetTick classes, which hook into the client-side prediction by adding themselves to the simulation graph. This is honestly the most beautiful code I've ever written, and I'm pretty proud of it, but don't take my word for it. Let's look at the numbers. So I benchmarked my new NetTick system versus my old custom character movement component, as well as a fresh default Unreal Engine project, to see the performance differences. The two most important stats that I measured were correction percentage and bitrate. Correction percentage measures how many times the client gets corrected for every move they perform. Corrections are like minor glitches where the player gets moved to a different location, and they appear as a stutter or rubber banding to the player. A lower correction rate means a smoother play experience. Bitrate means how many bits are sent from the client to the server every second, so you want to send as few bits as possible so that you don't congest the network. Sending fewer bits also reduces the likelihood of packet loss, and sending fewer bits means that you can support more players in a single match. So as you can see, my NetTick system averages around 1 to 1.5% correction rate, whereas Unreal Engine's solution hovers around 2 to 2.5%. The biggest improvement is that my bitrate is around 10 kilobits per second, while Unreal Engine sits at 20 kilobits per second. This is because of the algorithm I made to strategically cull and combine networked moves. I didn't show my previous custom character movement component here, but the stats were pretty bad, with a 4 to 5% correction rate and 18 kilobits per second bandwidth. So either way, this was a major improvement. After finishing NetTick, I added the first movement ability, the Impulse. This ability allows you to quickly dash in any direction, and it's very similar to the old dash in the game. My brother also created a new gun, the Ripper. This is our first SMG, and I'm really happy with how the art turned out. We still need to polish some of the animations and effects, but it's already miles ahead of the previous gun. Lastly, I got around to implementing a proper user interface for Astro. We added a speedometer on the left here because we really wanted to prioritize speed to the player. Other than that, it's pretty standard UI. So next on the agenda is adding the 2 other movement abilities, Teleport and Grapple. In the meantime, my brother will be making more weapons. Once we have all these features in place, I'm going to start the process of putting Astro on AWS servers, so we can finally run some official pre-alpha playtests. If you want to be one of those potential playtesters, give more feedback on the game, or follow development more closely, join our Discord. Links in the description. Thanks for watching, and stay tuned for the next devlog. Peace.
Already. You know what I mean? Like when you show gameplay.
No, I mean like...
You take that boost backwards, by the way?
That was good. I thought you were there, and then you just dipped. No!